Hello. Today I have with me some 3D printed objects, like this vase, a replica of a water slide, and even a 3D printed target. And our topic for this section is prototype modeling. And the idea is that sometimes you want to practice before you build something for real. You may be mass producing something thousands or millions of times, and maybe an expensive material, and you want to try that part out without all the expense. Or maybe you have some really large construction project and you want to build a small scale replica first to make sure it actually does what you want it to do. The nice thing about 3D printing is that you can quickly print something without a lot of setup and without a lot of expense or time. And so that's a valuable tool in the real world, and it's also a valuable tool for us as math modelers, because the things we learn when we do 3D printing can be valuable in other ways as well. For example, when we do mathematics, things are always idealized and perfect. Surfaces and graphs have no thickness, no error in measurement, everything exactly the way we design it. But when you actually build something, there's going to be thickness, even if it's a really thin metal or something. And if you are building something, there's probably going to be a little bit of measurement error or imperfections in the product. And all these things can add up to cause a problem that your mathematical solution didn't take into account. And so when we're doing math modeling, it's good to be aware of some of these issues that could derail an otherwise great model. And the modeling process and the 3D printing process have some other similarities. And that's this idea that sometimes you get in the middle of the 3D printing and you realize that something isn't working quite right and you have to back up. Or you get to the very end and it just didn't work out right and you have to start all the way over. So with that being said, let's take a look at the 3D printing process. And the first step is to have an idea. Maybe this is your mathematical model or something else that you're trying to build, but you have an idea. And the next step is you need to create an STL file. Now, generally to create an STL file, you're going to use something like OpenSCAD, Tinkercad, a computer algebra system, something that will create a stereolithography file. And CAD, by the way, stands for computer-aided design. Now in these videos, we'll mainly focus on Maple and OpenSCAD, or OpenSCAD, however you like to call it. And sometimes that can be easy. Sometimes that can just be a few commands in either system. Or sometimes this can be a challenge because going from our idea to an STL file that will actually work may be complicated because of some of those idealized differences between a mathematical surface, let's say, and what we'll actually print. But once you get an STL file, then the next step is to convert it into G-code. And for that, you need slicing software. I use Simplify 3D, but there's lots of options out there. But one of the things to be aware of is even now you're going to have to think about how many layers am I going to need for like the top or bottom of my objects. What sort of infill will I want? Generally, 3D printed objects aren't 100% solid, so you're going to have to decide for some number less than that. If you went 0%, that would mean it was hollow, basically, which is sometimes what you want. There's even things like supports. If you try to print something over thin air, that won't work, and so you'll need to build up some sort of support to get it to print properly. And even in the midst of all that, there's a whole lot of other options in the slicing software that can make your print turn out better. Now, we're not going to get into all those details because that would take too much time. But for lots of projects, just a very basic understanding will get you through no problem. But for other situations, you might need to do some more sophisticated things that will take more research or consulting an expert. So once you have the G-code, that's what your 3D printer will use to actually get you your print done. And so this will be our printed object. Keep in mind this could take a few minutes, but it could very easily take a few hours. So a 3D printer is very different from a paper printer. Very rarely can you just hit print and go on. As you can see, there's several steps. And even after your object is printed, let's say everything printed as expected, you're still going to have to clean it to get a final object. Now that cleaning may be pretty simple. It may be just sanding off a few burrs or something, or if something needs to be a little smoother, there may be some stray filament. You may need to break off some supports or dissolve them off if you have a more sophisticated model. But eventually you'll have that final object, but it may not be quite done because now you actually have to test and analyze this. So whatever your original mathematical model was, this is the object you're using to test that model to see if it did what it wanted to do. And when you do that test and analysis, maybe you had success and you're done. If so, great. But it may be that it didn't print quite well, and so you need to try reprinting. That can happen. Or maybe you need to slice it differently, and so you have to go back to this step. Or you may even have to go all the way back to the beginning and redesign your object if it didn't pan out the way you expected. And honestly, each one of these steps can sometimes have to cycle back if you need to. So just be aware, it takes a lot of perseverance to solve some of these 3D printing situations, but it can be a satisfying result when you have the actual object in your hand and it's doing what you want it to do. So keep that in mind when you are tackling these sorts of problems, and take advantage of the 3D printer if you have the opportunity. Now, for our purposes, for this section, we're going to do an example in both Maple and in OpenSCAD, and we'll do those in the next videos. So we'll see you there.